Hey gang, I'm going to show you two quick examples on how to find an inverse function using the flip and find approach. So the first thing you're going to do is you're going to rewrite this y equals 3 over negative x minus 2 plus 1. So then we're going to flip the x and the y, so the x is going to come over here, and it's become negative y minus 2 plus 1, and then we're going to solve for y. So the next thing to do is to move the 1 over here, so that becomes x minus 1 equals 3 divided by negative y minus 2. And then the trick here is I'm going to make this into proportion, and I'm going to cross multiply. So notice what I'm going to do here. I'm going to multiply these two guys together, the 3 and the 1, that makes 3. And that's going to equal these two guys multiplied together. Now I'm not actually going to FOIL these out. I'm going to leave these as separate. So it's going to be x minus 1, negative y minus 2. And the reason for that is now I can divide both sides by x minus 1. And that gives me 3 over x minus 1 equals negative y minus 2. And now I'm almost done. All I have to do is move the 2 over. So I get 3 divided by x minus 1 plus 2 equals negative y. And then to get y by itself, I'm simply going to multiply everything by negative 1. So if I do that, that's going to make my final answer, the inverse, f negative 1 of x, is going to equal, multiply everything by negative 1, I get negative 3 divided by x minus 1 minus 2. Now, the other thing I'm going to ask you to do is I'm going to ask you to find the domain and range of the function. So here's what I would set up. I would say, what's the domain of the function? What's the range of the function? And then what's the domain of the inverse? And what's the range of the inverse? Now, if you remember, there's a couple of quick rules about inverses and regular functions regarding the domain and the range. The domain of the function is the range of the inverse, and the range of the function is the domain of the inverse. It's easier to find domains than it is to find ranges. To find the domain of the function, I'm going to look right there, and I'm going to see that because of this part under here, the domain of the function is all real numbers such that x cannot be negative 2. Because if x is negative 2, then you wind up getting a 0 on bottom, and you can't have that. If that is the domain of the function, then that means that is the range. Now we have to flip it because ranges are y's. Y cannot be negative 2. So you see what I did there? The domain of the function is the range of the inverse. Next up, I'm going to find the domain, this part, of the function. So I'm going to look right there. Because of the x minus 1 on bottom, the domain of the function of the inverse is all real numbers such that x cannot be 1. Right? Because if you look here, you can't have a 1 on bottom, because if you do, it's a problem. Which means, this goes up here, this goes right there, the range of the function is all real numbers such that y cannot be 1. And there you have it. That's example number 1. Now let's do one more example. This one will be a little bit faster. If we look at this example, so I'm going to flip them around again. So it's going to be y equals negative n minus 3 to the 5th. Flip those, that's going to be n equals negative y minus 3 to the 5th. Now we have to solve for y, so the first step, divide by negative 1. So I get negative n equals y minus 3 to the 5th. And now to get rid of a fifth power, what I'm going to do is I'm going to take everything to the 1/5 root, because then that's going to cancel those out. So I'm going to get negative n to the 1/5 has to equal y minus 3. And now I can move that 3 over, and I'm almost done. F negative 1 of x is going to equal negative n to the 1/5 plus 3. And that's your function. Now, as far as the domain and the range is concerned, the domain of the function, the range of the function, the domain of the inverse, and the range of the inverse. Now, hopefully you remember what a fifth power looks like. If you picture the graph of a fifth power, x to the fifth, now this is a negative x to the fifth, so it's going to look like this. Right? So if you look at that, that means you know that the domain is all real numbers, and the range is all real numbers, which means same thing happens here. So those are pretty easy if you look back at the graphs. So what I'd like for you to do is I'd like for you to do the next two problems, two examples on your own, following the examples that I just did, and then we'll talk about them tomorrow and see how you did.